So let's consider a coin flipping game. I'm going to use this as my example for how to combine distributions. Let's say we have this coin flipping game. Heads, you win 7 points. Tails, you lose 3 points. 50%, 50% chance of each. On average, you will gain 2 points. The standard deviation is 5 and the variance is 25. And you can check this with your calculator. But you'll notice that standard deviation is 5, and always before we would have looked at this, it wouldn't have been exactly 5 because there was that missing. The point is that we're talking about a whole population here. So you can think of this as over the course of an infinite number of games, there would be half an infinity of 7s and half an infinity of negative 3s. And when you do that, the formula's whole n minus 1 thing, the difference between infinity and infinity minus 1 is basically nothing. So effectively that minus 1 wouldn't be there, which is why it comes out differently. The calculation is different for a population than for a sample. You don't just have a single 7 and a single 3. You have an infinite number of 7s and an infinite number of 3s. The calculation comes out a little bit different. You can take a look at the formulas if you want more detail. But basically, here we have our coin flipping game. And I want to know what happens when I combine multiple games. So there's 2 ways I can do this. The first way is I play the game twice. And the second way is I play the game once, but all values are doubled. So what I want to explore is the difference between those 2 things. Because you might think that the standard deviation will be the same, the variance will be the same for both those, but they're actually quite different. Consider it this way. If you play this twice, expected value of doing x and then another x, x1 and x2, well, that is 4. The average of the first flip is 2, the average of the second flip is 2, your expected value of 2 flips is 4. And no one's going to get exactly, no one would get exactly 2 points, but I don't have to talk about that. We already talked about that in the last video. Now, let's consider how this affects standard deviation and variance. When you do 2 separate events, you add the variances. Variance is how much randomness and noise there is in a situation. So if you do something twice, that doubles the variance. And that means the standard deviation, well, the standard deviation is the square root of this. So the square root of 50 is 7 point whatever. Now you might be wondering why it doesn't double, why the standard deviation doesn't just double. And the reason is that it's possible that those 2 events would cancel each other out. So yes, the overall noise has grown, but the distance from the mean hasn't doubled. If you do this in reality, there is a 25% chance that you will end up with 14 points. There is a 25% chance that you will end up with negative 6 points, but there's also a very large chance, 50% chance, that you end up exactly on the mean. And that means that even though some points are 10 away or 10 away, there's a lot of points that are not 10 away. So the standard deviation does not become 10. It just grows by square root of 2 in this case to whatever 7.07 something something something. Now this is in strict difference to, actually let me leave that there. This is very much different from what happens if you flip a coin once but double the result. When you just double the result, there's no way you would get 1 heads, 1 tails. It's all either double heads or double tails. So you have a 50% chance of losing 6, and you have a 50% chance of gaining 14. There's our probability model or whatever they're calling it in this chapter, as opposed to this, which is what happens if you flip a coin twice. So either way you're adding more variation to the overall total. But when you double an event, you double the expected value and you double the standard deviation, like we saw in chapter 2. But when you have two separate events combined, you don't add the standard deviations, you add the variances instead. So over here, this would come out 10, and this would come out quadrupled, not doubled. Yeah. Now this works even, variances add even when you subtract two events. Let me put it to you this way. What if you play this game with another person? You want to figure out how much better you will end up than they are at the end. So in other words, what's the expected value of you playing the game minus the other person playing the game? Well, 2 minus 2 is 0. Now, variance, do we subtract the variances or their deviations? If we did, we'd think there was no variation here at all. And that's not true. There is variation. Let me just make sure that the camera captures all this. Oh, good, it does. You might think that the variation will all cancel out, but you know that's not true in reality. In reality, there would be a 50% chance that you would both get heads or both get tails and end up even. There would be the 25% chance that you would get heads and they would get tails, and 25% chance that you would get tails and they would get heads, and either you'd end up 10 points behind your opponent, or you'd end up 10 points ahead of your opponent, because you get plus 7, they get minus 3, or vice versa. And I want to point out that the amount of variability here should be the same as the amount of variability here. They're both 10 away from the mean, and with a 25% chance probability on either side, and then 50% chance of the exact mean. So this is the same. Now, why is that? It's because variance is the amount of randomness. And when you do two events, whether you add the total or subtract the totals, the total amount of randomness grows. So whether it's plus or minus, sort of like absolute value, it doesn't care. The variance will grow. You add the variance in the first event and the second event, even if the totals end up being subtracted, because more randomness is being added to the situation by additional die rolls, by additional coin flips, whatever. Oops, minus x1 minus x, variance of x1 minus x2 equals 50, expected value of x1 minus x2 equals 0, standard deviation of x1 minus x2 equals 7.07. How do you actually do these calculations? If they tell you the expected value and variance of things, let me just say this, you can always add variances. If you have two separate events, I think I covered that in an additional video, so I'll let it wait for now.